Hello and welcome to the first episode of HowToByrd. Since I'll be doing a lot of 3D print time-lapse recordings in the upcoming videos, I decided a good place to start was a GoPro mount for my Ultimaker 2 Plus. So this design hasn't been fully sketched out. I have a rough idea in my head about how it's going to look, so I will be using the dimensions that are required for the Ultimaker's frame and the GoPro mount. Otherwise, a lot of the dimensions are going to be made up along the way. So it is semi-parametric design, and a lot of the design will be done organically. There are some mistakes along the way that I will go back using the Fusion360 timeline and fix. First of all, I started with a new file. I saved the file, and now I'm entering the dimensions of the Ultimaker 2 Plus's frame and the slot that will fit on top of the frame. So for the first step, after specifying the parameters that are going to be used in the first part of this assembly, I will start by drawing out and sketching the Ultimaker's frame, and then I'll move on to entering the dimensions of the clip that will fit on top of the frame. Now, to use a user parameter that was pre-specified, such as what I'm doing here, you just enter the name of the parameter and automatically Fusion will suggest the parameter that you have previously specified. Now, if for any reason you decide to change the parameter, you can just go back to modify, manage a parameter menu, and you just change the value of the parameter, go back to the model, and there it is. It's been modified in the model itself. Now, after designing the clip and extruding it, I'll move on to the two slots that will allow me to angle my camera and not have it fixed facing forward. So here I'm using the constraints to constrain the slots to the clip body and to each other, to have them equally placed and symmetrically placed in relation to each other and the clip. Now, the design I have in mind consists of 3 degrees of freedom, not taking into consideration the movement of the clip itself along the Ultimaker's frame. So the slots we are designing at this point are for the angular movement of the camera and the mount itself. Now, the next 2 degrees of freedom are going to be in the same direction, controlling the X and Y axis. The third joint would be that which is connecting the mount we are designing to the GoPro mount's hinge. So here I extruded the body around the slots, and I am filleting all the corners to make for a better looking design, and as well avoid having a lot of 90-degree angles, which are stress points and make it easier to snap the model at these points. As you can see, I constantly keep saving my design because you never know when Fusion decides to crash, and it's very important to keep saving your design or whatever you're doing, just to be on the safe side. Now here, as you see, I went back using the timeline. I modified the offset around the slots so as to make the body surrounding the slots bigger, and therefore allowing the chamfer around the slots to not affect where the slot starts and be just beside it. Now, since the body surrounding the slots was a bit too thick, I went back, modified it, made it thinner and better looking. Here I thought that to get a better grip around the Ultimaker 2, I can add a small extrusion in the shape of the clip itself by just offsetting the clip 2 times and extruding that resulting piece. Now, to allow for better 3D printing, whenever you have an overhang, I always use chamfers because they create this 45-degree angle, which makes it so much easier for the printer to achieve the overhang, and you avoid any slagging or bridging with the print. So one of the very cool features we have in Fusion is inserting and importing some components from other libraries or manufactured libraries. And one of the integrated libraries is the McMaster car library, which allows you to import screws, bolts, and a lot of other components directly from their library. You can also order the component and have it delivered to your doorstep, but in this case I'm just going to use it as a reference for my design. So after importing the screw, I created the sketch, and I'm sketching the grip that will be used in order to allow an easier tightening mechanism for the screw itself through the slot. After importing the screw, I created a sketch on the top face of the screw where I offset the screw's projected profile in order to allow for a better, easier fit of the gripping part, and then created the circle around that to allow for the rest of the part. Then what I did was create a mid plane between 2 edges of the hexagonal profile of the screw, and then use that to create a sketch in the middle of the screw. Once the sketch was created, I revolved the sketch around the middle axis of the sketch, and there you have it. That is the gripping part that I will use to attach to the screw to allow for a better look and an easier tightening mechanism. Now, to change up the workflow a bit, I went into Adobe Illustrator to create a logo that I will import into Fusion360 and extrude through the model, or into the model rather, to create somewhat of a better looking model. So what I did was I just put in a simple word which is time-lapse. I'll be using this product for time-lapsing 3D prints. Found the font that I like and changed the letter width of the font to give it a nicer feel. I decided to change the name of the product to Bird's Eye, since I'm the Bird House and the channel is HowToByrd, so it's more fitting as a name. After finishing the text part of the logo, I moved to the logo itself. 4 simple hexagons. I added a 4-point outline width and used 3 colors, one for each of the hexagons and the 3rd color for 2 of the left hexagons. Well, once I was done with the logo, I resized the artboard to the size of the logo. This is not required, but it makes it easier to move the logo around once imported into Fusion360. Then I saved the logo both as a PNG image and as an SVG file, which with the settings to convert it to an outline. Then going back to Fusion, I attached the canvas and attached the PNG image to the top face of the product we have designed so far, and then inserted the SVG file and rotated it, oriented it above the PNG image that was previously attached onto the top face. I then extruded the logo into the product, giving it a nice effect and branding the product with the logo. I gave each of the hexagons a different extrusion depth, just to give it a nice effect. Then I went back to the McMaster car library and imported the 8mm hex nut for the slot screws. Now I'm starting with the design of the next piece in this assembly, which is the bottom rotating piece of the mount that will be connected to the two slot screws that will allow it to move in an angular fashion. So after importing the hex nut, I created a sketch that's similar to the screw. I offset the hex nut by 1 millimeter and offset the inner part of the screw, which was also projected into the sketch, by 0.1 millimeter. Since the screw will be slightly sticking out of the hex nut, we want to create an extrusion to account for the screw itself, in addition to the hex nut, of course. So after doing that, I realized that I haven't created the joint between the hex nut and the slot itself, so I just took the dimensions of the hex nut and redrew it manually onto the projected sketch of the slot body. Using constraints, I constrained the hexagon horizontally and created a construction line between the top slot and the bottom slot to have them completely centered in the middle, and that will allow it to have a fixed distance between both, so it can move around in a single axis and not have constrained movement. Then I created a slot sketch and extruded the sketch upwards 2 millimeters through the hex nut. I then went back to the McMaster card library just to check the actual height of the hex nut, which was 2.4, so I changed the extrusion to 2.4 millimeters. Then I created another extrusion for the top part of the screw that I mentioned that will be sticking out for 0.5 millimeters, and then I closed the hex nut housing by creating another third extrusion, which had no holes inside of it, no openings, and then it was closed. I then created a fillet just to give it a nicer look, and went on to sketch the hinge. I entered the hinge parameters and started with the drawing. However, once I started drawing the hinge, I noticed that I had done the fillet a bit too early, since the housing of the hex nut was too small compared to the hinge. So I went back, removed the fillet, and started with the hinge sketch. Now, since I had the hinge dimensions and I've taken them from the GoPro company hinge, using a caliper, I entered them in the user parameters. I drew 3 rectangles, used the rectangular pattern command to duplicate the first rectangle, and entered the spacing that I wish. A very nice feature that you can do using the parameters is multiplication of the parameters and equations using the parameters in Fusion. The complexity of the equation is limited, of course. It is not to the extent that you can achieve using Grasshopper and Rhino, for example, but it does the job when designing simple assemblies and mechanical pieces such as this. As you can see, I'm using the equals constraint to fix the sketch in place and the components of the sketch. I then extruded the slots upwards, the hinge slots, and then the body that will hold the slots from the bottom. Then using the parameters I created a fillet and then a sketch on the side face of the previously created extrusions. I did the construction line, and in the midpoint of that construction line created a circle in which a 5mm screw will be placed in order to allow for the tightening mechanism and the hinge itself. So before we move to the screw, I wanted to embed the nut in the actual part in the bottom piece, and therefore imported a capped 5mm nut from the MacMaster car library. I then created a sketch and offset the nut's profile by 0.1mm to allow for easier fitting, and created a circle around that to have a closed sketch that I will be able to extrude, creating the housing for the cap nut. I then used fillets just to, as I said, avoid any 90-degree angles which will be mechanical weak points in the model and make it easier to snap, as well as giving it a better look altogether. Once the fillets for the extruded part of the hinge were done, I went on to filleting the actual body of the hinge. I tried a few dimensions since, as I mentioned, this design was not sketched or calculated beforehand, so I just used some trial and error and going back and changing the dimensions, looking at the design to achieve the desired look. So now, since the bottom piece was done, I moved on to the arm, which was going to lengthen the mount itself and add another degree of freedom between the flipped mount and the GoPro hinged mount, connecting them to each other. So I added two rectangles. Of course, as I mentioned, I added a small offset to each rectangle just to give them better fit with the other side of the hinge. Two rectangles on the left side fitting into three extrusions that we just designed in the previous part, and three rectangles on the right side which will fit into the GoPro company hinged mount itself. Now here I used constraints, drawing construction lines and using the midpoint constraint to ensure they are in the middle of the arm body. Of course, I then extruded the sketch using the user parameters entered previously and added some fillets to the hinge extrusions. I then moved on to add chamfers to the arm body to give it a better look and more natural feeling. Then, using sketches on the profile plane of the extruded hinge parts, I drew two circles on both sides and extruded them through the hinge slot extrusions. For the next step, I decided to give it a nicer look by using the Voronoi sketch generator which is a Fusion add-on, and I will add a link to the top right corner. Now, usually any Voronoi models can be done on Mesh Mixer for more complex models, but for simple hollowing out of a Voronoi tessellation, I use this plugin, which makes it very easy to generate a pattern using the density you desire and the size you desire. So I chose the holes I wanted to extrude through the arm and then extruded them straight through. As you can see, this gives a nice feel to it, but in order to avoid the straight edges on the top and bottom layer, I used the rule fillet and chose rounds only to create a curved surface at both bottom and the top faces. I then added a joint between the arm and the bottom piece of the mount, and it was a revolute joint, after which I proceeded to import a 20mm hex screw from the MacMaster card library. I bound the screw to the assembly using a revolute joint as well, and aligned it to the assembly by orienting the model on the right side. Of course, when you're orienting the model in order to align anything correctly, make sure that the view is perspective with orthographic views in order to get the straight line edges and avoid any perspective, which will cause misalignment. And then, as done before, I offset the screw's head profile and added a mid plane between two sides of the hex profile, and then using the spline tool drew a longer handle in this case which will fit on top of the tightening screw and allow for better grip. I then created a rigid hook between the screw and the handle in order to bind them to each other. And this way, if the revolute joint of the screw moves, the gripping handle will move as well with it. As done previously with the bottom mount, I wanted to include a capped hex nut to the other side, the bottom side of the mount arm. So here as well, I created an offset for better fit, a circle around it, extruded and then filleted to create the hex nut housing. As you can see, we are almost there. I added a few touches, so I went back to add some final touches to the design. I realized I did not chamfer the top face of the bottom rotating mount, so I added a chamfer to that, and as well as the arm itself. And then I changed the width of the arm because it doesn't require to be that wide for our application. Then copied the 5mm hex screw and the grip, and then joined it to the bottom hinge of the mount's arm. There you have it. This is the model we have. I'm going to print it and I'll get back to you and tell you about the results. Please subscribe and let me know if there's anything in specific you'd like me to cover or explain in my next video. Thank you.